and start that off for us. So welcome to the first day of organic chemistry. Those of you who are coming in, just grab a wipe, pick a row, make sure you go all the way, take the last available seat in that row so that any late arrivals will not have to climb over you. We do have a few less people in section 2 than section 1, so there should be a few empty seats available for you. So I'm Dr. Castle. I'm excited to be here teaching you organic chemistry today. We're going to start out by going over the syllabus. We're not going to read it word for word because I sent it out to you and hopefully you've already looked at it. Then we'll go over the article that I also sent out to you that was written by someone who took organic chemistry and does a nice job of explaining the expectations of the class and how to do well. Then we'll get into the beginnings of chapter 1, which will involve a review of the periodic table. And we may say a few words about bonding at the end of class. So this is a 100% in-person class, but because during the semester, I'm certain that there will be students with symptoms, and BYU requires anybody that has any COVID symptoms to stay home. And there may be students who are forced to quarantine at some point during the semester. And so we will be filming this class. You'll see Preston, one of our TAs here, is filming the class. And so videos of the class will be posted on, they'll be posted on YouTube, and then there will be links to those videos posted on Learning Suite, okay? So you're able to go back and look at any videos of any of our classes, whether you're here or not. It can be useful to help you review, even if you were here in class. But that's why we've got the camera here. I've got this AirPod mic in my ear, so if I don't hear you, just speak a little louder so I can hear you. And I'll probably be repeating the things if you ask me questions or answer my questions because my AirPod mic's not going to pick up what you say. So might be a little different at first, but I think we'll get used to how it's going to work. All right, so you should all be in section 2 if you're coming at 2 o'clock. And you need to come to the section that you are assigned, particularly you guys, because section 1 is full. And there weren't any empty seats in section 1 this morning, or not this morning, earlier this afternoon, I should say. And so in order to make sure there's seats for everyone, you do have to come at the time that you registered for. We will have in-person office hours. This is my office number. It's on the 4th floor of the Benson. I like to believe that I have the best view of any office on campus, okay? Our TAs have been to my office, and so they're nodding their heads. They know that I have an awesome view. So I know some students are intimidated or scared of coming to office hours, talking to professors. Please come to my office hours. I hope I'm not scary. I try not to be. But for nothing else, come up to the office hours and enjoy the view. I am only allowing one student at a time to come into my office. That's the capacity will be two people wearing masks. But here are the times, 4 hours throughout the week, 1 hour each on Tuesday through Friday at various times, that hopefully you would be able to come and get help on any of our concepts. So here we have learning outcomes for the semester. And I'm not going to read through those, but I'll just say that what we're going to focus on this semester is the basics of organic chemistry. So we're going to learn the fundamental concepts about structures of molecules, structural features of molecules that are responsible for their reactivity, and then we're going to learn about how molecules react with each other. So first we'll study structure, then we'll study reactions, and then at the end of the semester we'll study spectroscopy, which is how molecules, or how you can determine the structures of molecules. How do we know that the molecules have the structures that they do? It's spectroscopic techniques that give us that information, okay? So it'll be the fundamentals. You'll learn some reactions, and then in Chem 352M, there will be many, many, many more reactions that you will be learning. Our textbook, listed right here, the 5th edition of Organic Chemistry. This one is by Jan Smith and Heidi Volmer-Snar. This is what the hard copy looks like. You all should have, the default is for you to have access to the ebook through Learning Suite. I sent you an email about how that works, so if you have any questions, please feel free to ask now or later. But you have the ebook on Learning Suite. You have the electronic copy of the solutions manual to the homework problems, which you should be able to access through Learning Suite. If you have access to a hard copy or an older edition copy from a friend or a relative that took the class earlier, you're welcome to use that. If you do, then make sure you follow the instructions for opting out of the ebook on Learning Suite so you won't be charged for that. It doesn't matter to me. You just should do whatever you think is best for you in that regard. If you do use an older edition of the book, usually the 4th edition, occasionally the 3rd edition, two things to note. The homework problems are different, so you have to make sure that you download the homework assignment that matches the edition of the book that you're using. And then the other point is that there are a few concepts, a few topics that are in the 5th edition that are not in earlier editions. You will be responsible for those. There's not a whole lot of those, so I think you would still be fine. But just note that you're responsible for anything we cover in class that's not in earlier editions of the textbook. Okay? Any questions about our book? Good. Okay. So these learning outcomes that I have gone through basically cover, the first half of the textbook, chapters 1 through 15. It's a very well organized book, and so we will just go in order from chapter 1 through chapter 15. And this schedule here shows you the days that we will be discussing each of these chapters and the exams that we're going to have and which chapters those exams cover. Our first 3 exams will be held in the testing center, unless, of course, BYU tells us otherwise. We will be prepared, of course, if we know that at Thanksgiving we are going to all online instruction. And so the dates that you see with asterisks here, those will be lectures delivered online. We will film those lectures without students in the classroom, and we will post those lectures or the links to those lectures on Learning Suite. And then exam number 4, covering the last section of the class, will be an online exam. It'll be delivered through Learning Suite, as will the final exam. That will also be delivered through Learning Suite. And if we do have to go to online instruction earlier than that, then we would convert any of these other exams to online delivery, and we would start the online delivery of the lectures at whatever point BYU tells us we have to. But hopefully we can make it to Thanksgiving if we all work together. Okay, so these are the topics. Like I said, it's my favorite organic chemistry textbook, so I'm really glad we use it here at BYU. It's very, very helpful, very concise, so it's very readable, and it's very well organized, so it allows us to just go in order, chapter 1 through chapter 15, and I think that makes it easier for students when the order of the lectures matches the order of the textbook. Any questions about our schedule? Okay, yes? Do you need the textbook in class or just for the homework? Well, what you'll find is that the organizational pattern of the lectures will mirror the organizational pattern of the textbook by and large. We'll go through the topics in the same order. We'll present and discuss some of the same figures from the textbook. I won't just read from the textbook, of course, because that would be pointless. We will go into more depth on many of the topics, discussing why the concepts are the way that they are and so forth. And so it's not going to be verbatim from the textbook, obviously, but the order is going to be the same. So I would leave it up to you. If you find that bringing the textbook and following along in the textbook while I'm lecturing is helpful, if you're one of those people that takes notes electronically and you're writing notes in the margin of your textbook, in the ebook, then you would find that to be beneficial. If not, if you just like to write notes by hand, then you may or may not want to bring the book. So I'll leave it up to you. I definitely want you to read it before you come to class, though. Today, we're barely going to scratch the surface, which means that essentially we're spending about 3 days on chapter 1. So that means that by Wednesday, you should have the first third of chapter 1 read and come to class and be prepared to discuss and participate in class discussions about that. Question?
So I noticed you have the chapters for the specific lectures. Are you going to have sections for the specific lectures, or is it just do the third of the book?
Roughly a third of the book works pretty well. The book is well enough organized that we don't have to get quite that specific, and you'll just notice, okay, if there's 9 sections, then if you read the first 3 for the next class period, you'll be in pretty good shape for preparation for that class period. Okay, other questions? All right, so you see down here the assignments that we have. I already mentioned the exams. Those are worth 100 points each. They're a mixture of short answer and multiple choice. The online exams will be much more multiple choice, but we will have a little bit of a short answer component. And then we have our final exam. That's worth 2 times a regular exam. That's the bulk of the points, but we do have other assignments as well. Starting at the top here, we have written quizzes. These are quizzes that are designed to be of the difficulty level of the easier questions in the homework assignment. So we'll talk about the homework assignment a little bit later, but you do have assigned homework problems. And there are 2 types of homework problems. There are the problems within the chapter that you encounter as you're reading the chapter. And those are designed to be fairly basic level questions that are just checking how well you understand the concepts that you just read. Then at the end of the chapter, you have some more challenging problems, ones that I would consider either at an intermediate level or an advanced level. The in-class quizzes are designed to be at the difficulty level of the more basic questions, just essentially to check your understanding of what you read and not necessarily your ability to apply what you read to more challenging questions. They're designed to be about 5 minutes long, and we will take them at the beginning of class periods. We won't have a ton of them, right? Our class time is precious, and so we'll have a few of those quizzes. You'll note that I say here that we will have at least 6. The number of quizzes is yet to be determined. Some of that will depend on how many in-person class periods we actually get to have. And then it'll also depend on how the semester goes. If I feel that we need more quizzes to help you with your understanding, then we'll have more quizzes. If you're doing great, maybe we don't need as many. But we will grade your top 5 quiz scores, so you'll get a chance to drop at least 1 and possibly more quizzes. That also allows for occasional absences. You will be allowed to make up quizzes in the event of an illness, a family emergency. Normally I say university approved trips, but I don't think the university is approving a whole lot of trips right now. So most people should be here unless you're on the football team. They're the only ones that are competing right now as far as I know. So if you are sick, if you have any symptoms, any of the COVID symptoms, if you do your symptom checking on the app in the morning and you have any of those symptoms and it says you need to get tested, you need to stay home, you have to follow those guidelines, and then just contact me if you know that there was a quiz. I'm not able to contact, there's too many people in the class for me to reach out to everyone who misses, and I don't take attendance, and I will try my best to learn your names, but I'm not the greatest at learning names to begin with, and since I can only see your eyes, it's going to be a little harder for me to match names to faces this semester. So you'll have to bear with me in that regard, which means that if you do miss class, for one of those reasons I mentioned, if you're sick, if you're required to quarantine because your roommate's sick, if you have a family emergency, please contact me and we'll make arrangements for you to make up any quizzes that you might have missed, okay? As I mentioned, those quizzes are always going to be at the beginning of class. In normal times, I have those quizzes as unannounced pop quizzes. And the reason I do that is that I have found over the years of teaching this class and studying human nature that for some reason, students tend to be more prepared for class if there's a threat of a quiz, okay? And so I like it when students are prepared for class. We have a much better experience when students are prepared for class. It's better for all of us. And so even though it does cause a little bit of anxiety in some cases, I feel that the benefits of those pop quizzes outweigh the disadvantages. This semester, however, it's not practical because we've had to split this class into two in order to teach all of you in person. And I'm confident that at least 90% of you, if not 100% of you, would know in this 2 o'clock class that we were having a quiz if we had one at 1 o'clock. It would just be impossible for it to be pop quizzes in both hours. So in the interest of fairness, I'm just going to announce any quizzes. So let's say if we're having a quiz on Friday and Wednesday, I would tell you, okay, we're going to have a quiz on Friday, first thing in class. Make sure you're on time. We start when the bell rings. Usually bells ring. I don't know why they're not ringing today, but we start right on the hour. So you have to make sure you're here on time, and you would have 5 minutes to take that quiz. Question?
Are you announcing written quizzes or?
Yes, written quizzes, but not iClicker quizzes. We'll talk about iClicker quizzes in a moment. So what that means, that I'm announcing the written quizzes, that means you have to work extra hard to fight against that human nature that says, there's no quiz. I can avoid reading my OChem book for today. You got to fight against that human nature to be prepared for class, okay? Because we don't have the quizzes as a motivating factor. The pop quizzes as a motivating factor this time. And if you get behind in reading the book and being prepared for class, it's very hard to catch back up. So let's make sure that we are diligent in reading the book and keeping up with the lectures with both the book and the homework problems. Any questions about our written quizzes? So you see iClicker quizzes is the next point on here. Those are going to be worth 25 points total. There's a handout that explains how those are graded. So you will, for each iClicker question, you'll get 1 point for participating and 1 point for getting the right answer. The vast majority of the time, you will be able to talk to your neighbors. That's not as easy now as it is normally because your neighbors are further away, but we'll see how it works. And hopefully, many of these questions are designed to elicit class discussion. And so hopefully, we'll still be able to have class discussion in this era of social distancing as we are doing these iClicker questions. And the 25 points is a sliding scale. So what we do is at any point in the semester, we look at the total number of possible points, and 90% of those total possible points will be set as full credit. So that would give you an opportunity to have occasional absences, to have maybe a day where you forgot your iClicker, or a day where the battery died, although I do encourage you to carry spare batteries. That accounts for those sorts of occasional types of absences. The policy is not really designed to account for if you have to quarantine for 2 weeks. So if any of you get into that situation and you were missing large amounts of class and it would become impossible for you to earn more than 90% of the iClicker points, please contact me and I will make a note of it and I'll make sure to adjust that threshold for you so that it's still possible for you to earn full credit on the iClickers, okay? And then if we have to pivot to, the iClickers can only be used in class, and so we won't have any iClicker questions for points after Thanksgiving. It'll stop at that point when BYU pivots to the online instruction. Now, it does have to be the actual clicker. We're not set up in this class to use the app on phones. It has to be an actual clicker. I know there's a way to use the app on the phones, but it's not that straightforward from an instructor's perspective, especially if you're using both. And I wanted to figure out how to do that before this semester started. But I must confess, I'm not a high-tech individual. I'm a low-tech guy. And I spent most of my time trying to figure out the best way to film class before we started this semester. So I ran out of time to figure out how to incorporate the app for the phones on the iClicker. So forgive me for that. You do need a physical iClicker. And the document that's on Learning Suite will explain to you how to register that. It's very, very simple. And our first questions will start on Friday. So we'll give you some time to acquire that clicker and register it. The iClicker questions will just come, they will be unannounced. They'll just come at various points in the lecture, at the natural points where they will help us elicit class discussion during the lecture. And so we won't have them every day. Some days are well suited to them. Other days, the material's not as well suited to them. So some days we'll have them, other days we won't. But just make sure you bring your clicker every day, starting Friday, and you're ready to participate with it. Any questions? Okay. Then we will have a written assignment, a written report. We'll talk more about that later in the class. But basically, because this is a majors class, it's vital for you to see the connection between what we're learning in class and between cutting edge research that is being published in peer-reviewed journals. So what you will do for this assignment is you will select a recent article published on any area of organic chemistry, but organic chemistry has to be the main theme of the article. You'll read the article and you'll write a brief summary. Okay? Now, I don't expect you to understand everything in the article because usually these articles are geared towards graduate students and up. Okay? But I do know that by that time in the semester, you'll know enough organic chemistry that any article that you read, you'll be able to learn something. Okay? And so I will just ask you to read that article and summarize what you learned from that article. And that's just designed to connect what we're learning in class with what practicing organic chemists are doing in the lab. Usually it's a fun assignment. It's hopefully going to be fun and educational. Then we have a spectroscopy quiz. This is a take-home quiz. This spectroscopy is one of the last things we cover in class, which is actually good this semester because the spectroscopy quiz is a take-home format. It's well suited for that take-home format, and so you'll have a take-home quiz on spectroscopy after Thanksgiving, due at the end of the semester. Okay? Now, over here, you will see this is kind of a rough grading scale for the class. It means that in the history, at least that I've been here, which is not yet ancient history, but I have been here at BYU for quite some time teaching this class, roughly a quarter of the students usually end up in the A or A minus range. Close to a third of the students end up in one of the B ranges, and so on, based on these percentages that you see here. Okay, so the way the grades are assigned, we're going to combine the two sections because they'll be virtually identical classes, and we'll just look at all the raw scores, the point totals that you have at the end of the semester, and we'll look where there are natural breaks between groups, and then that usually turns out to be the letter grades, and that usually turns out to be pretty close to these percentages that we see here. Okay. But please listen to this closely. Please do not misinterpret this to mean that there's only a limited number of A's available in this class. Nothing could be further from the truth. That is absolutely untrue. Usually what happens is that the line between that upper 25% and the next 25% usually comes somewhere in the mid to upper 80s, okay? And the line between the B's and the C's, that usually comes in the mid to lower 70s. So what that means is there's usually a curve that helps students in this class in recognition of the fact that this is a challenging subject. Organic chemistry is a challenging class. I realize that. And so usually these percentages here will actually help you. And my promise to you is that if you guys turn out to be the best class I've ever taught at BYU, and all of you end up with 90% or better, you're all going to get A's or A minuses, okay? I promise you that I will award you the grade that you earned. Every student in this class will get the grade that they earn, okay? So what that means is you are not in competition with each other for a limited number of A's, okay? That is not the case. Anyone who earns an A will get an A. Historically speaking, usually the class sorts itself into these different categories, but it doesn't have to. If everybody is an A student, then everybody gets A's. Okay, so this is just based on typical performances of BYU organic chemistry classes. Any questions on the grades? All right, so you don't see homework listed here, and I have mentioned the homework, and the homework is a vital part of the class. So let's talk about the homework briefly. On Learning Suite, there are assigned homework problems. There should be 3 documents, one for the 5th edition, one for the 4th edition, one for the 3rd edition. right? So make sure you get the homework assignment for the edition of the book you're using. And the homework problems that are assigned represent roughly half of the homework problems that there are. I've chosen the ones that I like the best, although even the ones I haven't chosen are very good practice and preparation. Normally, a neat notebook containing all of your solutions to the problems is due at the end of the semester. We won't be meeting in person at the end of the semester, so we're going to have to do it a little differently this year. And the handout explains how that's going to be done. Just briefly, I'll tell you how it works. The homework is worth 6 points total. That doesn't seem like a lot, but it's calibrated specifically to be the number of points that approximately 10% of you will end up within the next available letter grade. So in most of the classes I've taught over the years at BYU, usually about 10% of the students end up within 6 points or less of going from an A minus to an A, or a B plus to an A minus, okay? So what happens is, once I've determined the breaks in the curve and figured out the ranges of points for each letter grade, I'll look at the homework of those 10% of those students, and I'll grade their homework based on the percentage of problems they've completed, and that's out of 6 points. And if those students earned enough points to show that they deserve that next higher letter grade, then that's what they would get, okay? This semester, you're not going to be here to turn in your notebooks. So what we'll have you do is we will have you self-report the number of problems that you completed, number of assigned problems that you completed in each of those chapters, and then calculate a score out of 6 points, okay? And if you turn out to be one of those students that's within 10% or one of those 10% of students that's within 6 points of the next available grade, at that point, at the end of the semester, I will contact you and I will say, I will pick 2 chapters at random and say, please take pictures of your solutions to those 2 chapters that I've chosen and email it to me, and I'll check it to make sure it matches what you self-reported. Okay, and if it matches what you self-reported, then you'll get the score that you reported. Of course, if it doesn't match what you self-reported, then you won't get any points. So it has to be reported accurately. Okay? Any questions about how we're going to do the homework? Homework is a vital part of the class. Okay? Even though it's only worth 6 points, I've explained to you why it's worth 6 points. Practically speaking, it's to make it so it's manageable for us to grade the homework. But it's also there to give you an incentive, to give you a reward. It rewards students who do the homework. And as you'll find, and I'll reiterate, doing the homework problems is usually the best way to prepare for the exams. Okay, so you'll get extra benefits if you're doing the homework as you go in your exam preparation. There's an extra credit assignment. It's meant to be a fun assignment where you can get together in groups, usually small groups, and create a music video, usually a parody of a pop song or something like that, where you've changed the words to be organic chemistry themed lyrics. Students have a lot of fun with this assignment, those who choose to participate. There are lots of examples. If you go to Learning Suite to the Music Videos tab, you'll see documents that contain links to videos that were submitted in earlier semesters that can give you some ideas for this. That's due at the end of the semester, but given that we are scattering at Thanksgiving, this year it would be wise, if you're going to do this, to do it before Thanksgiving. So TAs and tutorial labs, we have 2 fantastic TAs here. I'd like to have them stand up and I'll introduce them. We have Josh right here, and we have Preston. He's doing the filming for us. He's right here. Josh was a TA for Chem 351M and 352M last year and did a fantastic job. Preston was in my Chem 351 class a year ago and was one of the very top students in the class. And so I am completely confident that we have 2 of the best TAs for organic chemistry at BYU in this class. And so I strongly encourage you to take advantage of their wisdom, their expertise, their keys and secrets to success. Okay? Thank you. You guys can sit down. So BYU has decreed that interactions between TAs, at least in the chemistry department, between TAs and students is going to be all virtual this year. So we will have an online virtual tutorial lab where Each TA will be available for I think 2 hours, maybe 3 hours a week. And that schedule will be posted once it is determined. We're determining the schedule this week. And so once we have the schedule, we'll make sure it's available to you. And you can use it much like you would have used the physical tutorial lab. You can just drop in on Zoom and ask questions on any homework problems or any concepts that you're having trouble getting answers to. This class does not have official recitations. So what we do is we have unofficial recitations for this class, where each of our TAs will be available for a Zoom recitation section 1 hour a week. And in that recitation, they will do different things depending on what's on the schedule. If we have an upcoming exam, they'll probably spend time reviewing for exams. Otherwise, they'll probably go over some of the more challenging homework problems and kind of help you work on those homework problems in a group setting. Sometimes they come up with their own homework problems and spend a little extra time explaining concepts that are a little more challenging that we've learned recently in class. So those sorts of activities. What I would like you to do this week is email our TAs. You should be able to email them on Learning Suite, and it doesn't matter who you email, but just email one of our TAs and tell them when you would prefer those virtual recitations to take place. And we'll do our best to pick times that fit in the majority of your schedule, but also fit in the schedules of our TAs. And then remember, I have office hours too, and we'll try to schedule those different from my office hours so that we're trying to cover as many different hours of the week as possible for you to be able to get help. Okay? Any questions? All right, so rather than read the helpful hints, let's talk about that article that I emailed out to you, the New York Times article, because a lot of these helpful hints are covered in that article. So this was an article written by a science journalist who decided she wanted to change careers and go to medical school. So she took organic chemistry at Harvard, and then she wrote about her experiences. And even though it was designed for a pre-med audience, I'm sure some of you are pre-meds, but many of you are not. There's a lot of valuable information in this article, even if you're not a pre-med, regarding expectations for this class and how to be successful in this class. So what I'd like you to do is raise your hand and tell me one thing that you learned from reading this article. Okay, please. Humble. Okay, so humility is essential. That was one of the things the students mentioned in the previous hour as well. And that's a great lesson. It probably tells me you've been reading your Come Follow Me assignments, because if we've been reading the Book of Mormon recently, we've been learning a lot about pride and about how pride causes a lot of problems. And of course, the opposite of pride is humility. And humility is essential to learning organic chemistry. There's a very, very small fraction of the population of the world that are natural organic chemistry geniuses. This stuff is just going to come really naturally to. But the vast majority of us, myself included, have to be humble and teachable in order to learn the subject. Okay, so it does require humility for success. Excellent. What else did we learn from this article? Yes, Roger. Time. Okay, 2 key points that Roger mentioned there. So he said you've got to put a lot of time into the class. And he also mentioned that it involves a lot of spatial reasoning skills, being able to look at molecules drawn on paper and have a vision in your head of those molecules in 3 dimensions. Both of those points are critical, so I'm glad you mentioned them. Everybody wants to know how much time you have to study for a class in order to be successful. For organic chemistry, there is no formula. I'm very sorry, I cannot give you a formula for this class. And that's because this material, it actually ties into the other answer Roger gave. Organic chemistry is unique compared to the other science classes that you've had and to most of the ones that you will have. Most science classes are either highly math-based. General chemistry had a lot of math. Certainly physics has a lot of math, where a key skill there is identifying the right equation to use for each individual problem. We have almost no equations in this class. Okay, we probably have 1 or 2 equations, and that's it. Okay, Other science classes, such as anatomy, some biology classes, require you to memorize huge lists of terms. We don't have that either. We will have some things that you need to memorize. We try to minimize memorization. We cannot eliminate it, but you're not memorizing huge lists of terms, okay? What you're going to have to do is you're going to have to learn concepts, and then you're going to have to be able to apply those concepts, okay? And a lot of it involves the skill that Roger mentioned, which is looking at a molecule on paper and having a three-dimensional vision in your head. You can certainly use molecular models to help you with this, and I strongly encourage that. When we get into chapter 4, we'll talk about that in more detail. But that's a vital skill. And because that's not something you've learned, unless you've taken art classes, that's probably not a skill that you've learned. So you don't know, you have no idea if you're good at it or not. Those of you who are good at it, you'll pick it up pretty fast. Most of us aren't, and it'll take us a while. You'll have to read and reread and come to class and do homework and spend a lot of time before you feel comfortable mastering the material. So because of that, I can't tell you how many hours a week you should spend studying organic chemistry. What I can tell you is this class should be among your highest priorities in life this semester. That's a way to ensure that you're going to be successful. If you have it way up there on your priority list, you'll have a better chance of being successful than if it's buried at 6th or 7th or 8th or whatever on your list of priorities. Okay? And so my answer to how many hours it's going to take is however many hours it takes for you to feel comfortable that you've learned the material. I will say this, though. I'll say that since I recognize that this is a challenging class and it does require most students a lot of time to master, that I have done my very, very best to trim out anything that is non-essential. So all of our assignments that we have, all of the time that we spend in class, it all has a purpose designed to help you learn the subject effectively, okay? We don't have busy work because there's no room for it, okay? Everything, all the time that you spend should be purposeful and should have a purpose. So thanks, Roger. Excellent points. Anything else? What else did we learn by reading this article? Yes, please.
One thing that I thought was kind of impossible to completely understand everything, so make sure that you know a little bit about everything.
Okay. That's true about anything in life. I don't think there's anything that I perfectly understand. That goes along with the humility. And so this is an introductory organic chemistry class. It's your first organic chemistry class. So certainly we're not going to understand everything. But if you go for an understanding at the level that the material is taught in the book and in class, then you'll be in good shape. Okay? Good point. Other things that we learned from reading this this article. Yes, please.
It's important to know when to stop, like perfect and start doing things.
Okay, so you said important to know when to stop striving for perfection and then just doing damage control or just trying to salvage something out of the problem. So that's what she was talking about, I guess, in her experience on the final exam that she was taking. Indeed, we give partial credit on challenging problems. We will have challenging problems that probably in most classes, maybe 10% of the students will get full credit, right? But you should be able to get a lot of partial credit if you're, on those sorts of problems. So don't give up. I would say a better way to phrase that is don't give up if you aren't perfect on the problem, right? Because you don't have to be perfect. We don't expect first year or organic chemistry students to be perfect, okay? There was something else she mentioned. Well, I'll ask for any more things that we learned. Yes. Yeah. Okay. So you're taking inspiration from the fact that the author here was 42 and had 2 children when she was taking organic chemistry, and she did well. She got an A-. So yeah, if she can do it, why can't you? Exactly. So it's definitely possible. It is a challenging course, but it's certainly not an impossible course. And so definitely, that's a great point. We can take inspiration from her experience. It should be giving you some hope. Okay. One last thing I would like to call your attention to is her concept of organic chemistry intuition. She said that that was essential. Once she developed organic chemistry intuition, her scores on exams went up. Organic chemistry intuition, I would define that as understanding the concepts well enough that you can look at a challenging problem that you haven't seen before and solve it using those concepts that you've already learned. Okay, those are called challenge level problems. And when you start getting into the homework, you'll see that at the end of each chapter, there's usually a set of about 3 to 5 problems that are challenge level problems. And it requires organic chemistry intuition to solve those problems. And those problems are going to be roughly equivalent to the difficulty level of the hardest problems you'll see on the exams in this class. Of course, not all of the exam questions will be challenge level problems, or you'd never be able to finish. But there will usually be a handful, maybe 2 or 3 problems per exam that are at that challenge level. Okay, and when you have that organic chemistry intuition, you'll be able to solve those problems. Okay, so the way to how do you get organic chemistry intuition? Practice. That's the only way I know of to get it. So you need to read the book. You need to make notes of questions that you have on things that you don't understand when you read the book. Then when we come to class and we discuss what was read in the book, make sure to ask those questions that you don't understand. If they don't get answered in the course of the class discussion, please ask those questions. Make sure you work the homework problems while you're reading the book, and then make sure you check the answers. And if you're not getting them correct and you don't understand why, make sure you contact me or the TAs to understand why. Okay? So those are the ways that you develop that organic chemistry intuition. Through reading the book, being an active participant in class, working the homework problems, and getting help on anything you don't understand. Okay? Any questions? I would encourage you to refer to this article frequently throughout the semester because I do think it's helpful in helping you set expectations for the class. I think that her description is quite accurate of the experience of many students. And so I think, and it can also give you hope, as you mentioned. Okay? All right. So for the last 10 minutes or so, let's get into a review of the periodic table. So I've written on the board some of the key topics from chapter 1. Bonding, Lewis structures, bonding theories, electronegativity, and polarity. These are all topics that you've learned before. All of you have taken general chemistry in some form. Some of you, maybe the last time you took it was AP chemistry in high school. Some of you may have taken Chem 111 and 112 or 105, 106 last year. Some of you may have taken it and then served a mission and then returned. Some of you may have taken it, changed your mind on your major, and then changed your mind again. It doesn't matter. All of you have learned these topics at some point, I'm confident. And whatever you've learned on them is presumably sufficient for what we're going to discuss in this class. Okay? So don't worry a whole lot about your general chemistry knowledge being old or dated or anything like that. Usually it's not a problem in this class because the aspects of general chemistry topics that are relevant to this class are usually the ones that most students remember. I will say one thing here about Lewis structures. We're going to focus on resonance structures in this class, which you may or may not have learned in your general chemistry class. I cannot overstate how important learning resonance structures is, okay? Students in general who understand resonance structures well, and we'll start to get into that either on Wednesday or Friday, but students who understand resonance structures well tend to understand reactions well. The converse is also true. If you struggle understanding resonance structures, you usually struggle understanding how reactions work. And once we get into chapter 6, that's when we're going to start discussing reactions. So if at the end of chapter 1, you're struggling with resonance structures, make sure you get help from me or from the TAs because this is a vital topic for you to do well in this class. The other topics are important as well, but I would say this one is vital. So let's start with the periodic table. We've got one here on the screen. We've got the one over here on the wall. Let's start at the very top. Row 1. How many valence shells of electrons do we have in the atoms of row 1? One valence shell of electrons. How many orbitals are in that valence shell? One orbital. How many electrons can fit in that orbital? 2 electrons, okay? And what do we call that one orbital? It's an s orbital, okay? Very good. So because we can only have 2 electrons in that first shell, we only have 2 atoms in row 1, hydrogen and helium. Let's go to row 2. How many shells of electrons do we have in the row 2 atoms? Okay, I think I heard 2 out there. Indeed, we have 2 valence shells of electrons. Or, I'm sorry, I said that wrong. 2 shells of electrons. How many of those shells matter? Just one of them does, right? The valence shell, the two level is the only one that matters. Those 2 electrons in the 1s orbital are buried. They're so low in energy that they're not going to participate in reactions. So because of that, in organic chemistry, we're interested in reactions. And so we're only going to care about the valence shell of electrons. So let's look at that valence shell in that second row in more detail. So how many orbitals are in that valence shell? I didn't say how many different types, I said how many orbitals. Okay, so it's a slightly different answer. You can call out this answer, presumably. I see people raising their fingers, and now I get the right answer. Okay, 2, 3, and 4 I've seen. There are 4 different orbitals in that second valence shell. So what are they? Who can raise their hand and tell me one of those 4 orbitals? Go ahead. Okay, so we have a 2s orbital. And what does the 2s orbital look like? It is a sphere centered on the origin. Okay? Who can raise their hand and tell me another one? Yes. 2pz. All right, you chose Z first. So we have 3 p orbitals. Each one is centered on one of the axes in 3-dimensional space. So we'll just do it backwards, I guess. Pz, py, and px. So, and what do these orbitals look like? Okay, you could say a dumbbell, a figure 8 also. Some of the d orbitals look a little more like dumbbells, so although they do look like that, I prefer to visualize them as a figure 8. So we'll have 2pz, a figure 8 centered on our z-axis. You'll see I'm not a great artist, but I have been drawing these things for decades, so at least I can sort of draw orbitals. You'll see that I'm shading one of the 2 lobes of these orbitals that I'm drawing. That is because an orbital is just a fancy mathematical equation describing the properties of an electron wave. So it's a mathematical equation, which means that it has a value and a sign at those positions in space where it exists. And so the shading versus the unshading is just to indicate the sign of that orbital or that wave function, that fancy mathematical equation at that position. Okay, so shading is one sign, unshading is the other sign. Okay? All right, so how many electrons fit in each of these atomic orbitals? 2. So that gives us 8 electrons total in that second valence shell, which is why we have 8 elements in that second row of the periodic table. So, based on what we've discussed just in the last 6 or 7 minutes, we can understand why carbon is the backbone of the molecules of life. Most of the molecules in our body, most of the molecules that enable life as we know it, including synthetic molecules, are based on carbon chains and carbon rings, long chains of carbon atoms or rings of carbon atoms bonded together with an occasional oxygen or nitrogen thrown in, but it's very rare for us to have 2 or more oxygens or nitrogens connected to each other. It's usually carbons in these chains and rings. Why is that? Based on what we've discussed so far, we can answer that question. It's not easy, but hopefully we can try. Yes? Okay, so carbon has 4 electrons. That's exactly it. Carbon has 4 valence electrons. So how many bonds can carbon form? Carbon can form 4 bonds. If it forms 4 bonds, how many lone pairs or non-bonding electrons are left over? 0. So carbon, because of its position in the periodic table, is able to form 4 bonds and have no lone pairs left over. And that is vital, because if you had a chain of atoms that were bonded together, and each of those atoms had lone pairs on them, what would happen? What would those lone pairs do to the lone pairs on adjacent atoms? They'd repel each other, and you would have an unstable molecule. Okay? So you can have chains and rings of carbon atoms with no lone pairs repelling each other. You do have an oxygen or a nitrogen thrown in here or there. You have halogens coming off of the chain sometimes, but those lone pairs are fairly isolated, and they're frequently not repelling other lone pairs in the molecule. So carbon, because of its position in the periodic table, is uniquely suited to be the backbone of the molecules of life. That's why organic chemistry is so important. You might ask the question, what about silicon? Silicon has 4 valence electrons. It can form 4 bonds and have no lone pairs. Why don't we have life based on silicon? We can also use the periodic table to answer this question. Yes? It's more reactive, so it's going to be chains of silicon atoms are going to be less stable than chains of carbon atoms, so they would be more reactive. But why? Any answers? Yes. Yes. You hit it. Because silicon is bigger, the bonds between silicon atoms are going to be longer, and longer bonds are weaker bonds. Okay? So carbon is the ideal element. Carbon is by virtue of its column and row in the periodic table, it is the ideal element to be the backbone of the molecules of life. And that is why organic chemistry is so important. I love organic chemistry. I'm grateful that I get paid to do something that I really enjoy, that I get to teach you about how fun and exciting and important organic chemistry is. And we'll end for today on that note, and we'll start again on Wednesday talking about covalent bonding. As you leave the room, please leave out exit out one of our approved exits. Please drop your information sheet if you filled it out on one of the desks or chairs near that approved exit. If you have not filled out the information sheet yet, please fill that out and bring it back on Wednesday. I depend on those to help me to get to know you, which, as I mentioned, is going to be extra hard now since I can only see your eyes. But I'll try my best to get to know you. So thank you, and we'll see you on Wednesday.